Okay, good afternoon, everyone. So, welcome all to the second session of Tinker Bharat event. That is Tinker teachers for the event. Okay, actually, we have just sent a reminder. So, uh, let's wait. Okay, let's start the session. So, in the first session, I hope you guys have remember we have discussed about the introductory session on the STEM, how STEM is changing the domain, and what is our most important areas where we can work it out. Okay, how we can relate the scientific concept in such a way that they can student can feel the touch of the technology, and at the same time they can understand like how what is the field they can understand how the technology works and what is the scientific concept behind it, and at the same time you can teach the concept in of such a simpler form that they are easy to understand and being with them for long duration of time. So keeping that in the mind, we'll be starting today's session with a software that is called Tinkercad, where we'll be discussing about the electronics or the circuits. Okay, how that works and how you can teach the concept like voltage, current, resistance, the different electronic components like LED, batteries, okay, to the students so that they can understand the technology that they see around in their daily life. So, okay, let me present my screen with you. Oh, sorry, very sorry for the. I forgot to switch on the mute. Okay, so in the today's session, we'll be discussing about the electronics, as I had told you. But this session will be on the virtual platforms. So I hope you are being connected through the laptops or a computer. Okay, so that you have an internet access where you can easily open the website. So to open the website, okay, we'll be working on a website called Tinkercad. Okay, so today's sorry, today's website that we'll be looking after is called Tinkercad. You can search in your Google Tinkercad. Okay, and this will be the website that we'll be working on, where we'll be doing the simulation for the different electronic activities. Okay, so when you open this website, okay, when you open this website, it will ask you about a login option. Okay, let me log out so that I can show you guys. Okay, so this screen will be visible to you whenever you open the website Tinkercad. Okay, here you will get a two option. One is login, another one is sign up. So if you already had the account, you can go to the login. But most of you will not may not have the account. So I'm going to show you how you can create your own account in a very short duration of time. So go to the sign up. Okay, here you have to start as a create a personal account. Okay, you can mention your schools also, but because we'll be practicing as a personal account, so yes, go to the option create a personal account. Okay, then you will get a option, multiple option, like if you are using an Apple device like Safari and etc, so you can log in with the Apple. But most of you already have your Gmail ID, so go to the sign in with Gmail, and your Gmail IDs will be opened over here. Okay, so you just have to click on one of the ID that you have, and it will automatically sign you up for this platform. Okay, so since I already have the account, so I'm going to choose the other option, that is login. Okay, personal account, and going on the sign in option, I will choose my account, which I already have been using on this platform. So this is a open source platform. Okay, it's made up by Autodesk, which you already might be using a PDF reader and every different options. So Adobe or the software that you use is basically from the same. This is from the same company. So here you will get an option like your profile will be there, and you will get an option like you can design the thing, or there is an option for tutorial where you can learn how to design the things. So we'll be keeping on the design part. In this Tinkercad, basically these this platform can be used for multiple things. Okay, you might be aware about 3D printers. Okay, so there is an option of creating 3D design. Later in the later session, we'll be discussing how you can design any objects on a software, which you can after that, which you can give a command to a 3D printer to print it out. Okay, but today what we are doing, we'll be learning about the circuits option. So when you go to the Tinker drop down menu, you have to select a circuit option. Okay, so after opening it, this kind of page will open, and here you can put click on the start tinkering, and your website will open. So you will get an option like a circuit. If you want to create a 3D design, you will get an option like this. If you want to create a circuit, you will get an option like this. Okay, in the corner you will see the option new plus. So if you click on this, you can do multiple things, like you can create a 3D design, you can create a circuit, or code block. If you like doing coding, you can use this platform to learn the coding also. So आज जो हम चीजें सीखेंगे, that will be around the circuit. So let's click on the circuit part. Okay, so this kind of platform, this kind of page will open, this kind of window will open on your on your laptop or on your web browser. Here you can see all the electronics components that been used to create a circuit. Like there is a photoresistor, diode that you teach to the students. There is a RGB LED. Okay, voltage. For the voltage, we have a battery, potentiometer. You have already been teaching them the concept in the physics, like potentiometer where the resistance vary with each other, capacitor, switches, okay, push buttons. So these are the options of electronic component that is available. So these are the basic thing. If you go to the other menu and want to see all the electronics option, okay, so it will give you a detailed vision of all the options of electronics that is been available here, like polarized capacitor, inductor, Zener diode. So these concepts that you are teaching to the students in their academic, you can teach them through a practical experience where they can simulate a circuit and understand how these things work. Okay. So today we'll be doing a little basic activities where we'll be learning about the concept of voltage regulator, voltage, current, electricity, voltage, current, resistance. Okay. You Ohm's law. What is Ohm's law? How the basic circuit can be created. Okay. And how it can be taught to the students. So when we start with the concept of voltage, current, and resistance, okay, I think as a teacher you already know the definition of all these components, so we are not going to go in the deep definition part, but how to give them an analogy that they can easily understand these concepts, that will be the main part. Okay, most of you teachers are already might be doing this where you are giving such kind of analogy to the. Okay, someone has asked about the circuit tab. Okay, so let me go back to the part, like whenever you log into the platform, okay, you will see this kind of uh, profile, right? Here you have to go to the new option. Okay, click on the new and click circuit. After clicking on the new, click circuit. So this kind of platform will open. Since it already been opened, so I'm going to show you same platform that we are discussing about. This kind of window will appear when you click on new circuit. Okay, so we are talking about voltage, current, resistance. So we have already learned about the Ohm's law, where there's a correlation between the voltage and the electric current that it flows with it. Okay, so V is equal to IR is a formula where resistance is a value that been calculated, and according to that voltage and the current flow. So I was talking about what kind of analogy as a teacher you can give to the students, or how you can teach these concepts in a very easy manner. Okay, so the analogy that usually being taught is basically, or you might already been giving it to the students, is a water tank analogy. Okay, so like there's a water in everyone's house, there's a water tank above where the water is there, and the whole house is being connected through a water pipe. Okay, and to access that water, what we have a tap. Okay, so when we talk about voltage, voltage is like a pressure or a force that pushes the electron from positive to the negative end. Okay, and this flow of electron is called current, and the resistance is what you can say opposite force that been applied on the electron to resist the flow of the electron in the conductive surface, that is called resistor. This is the basic definition that everyone is been teaching them. So when I talk about the analogy that I was discussing about water tank, so water tank is like a voltage, okay, where the water is being stored at a height, okay, and continuously is the weight of the water is pushing through the water pipe that been distributed among the house. So to access the water, what we have to do, we have to open the tap. So tap is like a resistance. So whatever quantity of water we require, how much speed or how much volume of water we require, we open our tap accordingly. So if we require very slow, if we are washing our face and something, we open a very little bit of tap to access the water, and we can easily wash the thing. But if we are using it for filling the bucket or using it for washing the car, so we need a force, we need a pressure and high volume of water. So we have to open the tap to its maximum. where the more water can come. So this is the analogy. So the stored water in the tank is like a voltage which is exerting the force, and the water that is flowing in the water pipe is like a current. Okay, and the water pipe is a conductive conductive object or a conductor, okay, through which the current flows. And the tap is what? Tap is a resistance. So accordingly you can vary the resistance, and the required amount of water can come accordingly. So this is the analogy that we give to the students while discussing about the concept of voltage, current, and voltage, current, and resistance. So after training, after giving this analogy, the next thing is how to give them a practical exposure. So one thing is that you might have an electronic kit with you in the lab, where they can go and they do the practical experiments, or you can have this kind of platform that is called Tinkercad, where you can easily do the online simulation of a circuit, where they can understand how the current is flowing, how the electronic components are being connected, okay, what is the positive and negative terminal of those components. So they can easily understand the concept. So today we are going to make a first basic circuit, basic circuit that been taught in grade 6, where we are going to connect a power source with a LED, a switch, and a resistance. Okay, so this is the basic circuit that we have learned in class 6, where when the circuit is being introduced as a subject. So today we'll be doing that activity. So to perform this activity, first component that we require is a breadboard. Okay, so this is an electronic component that being used for prototyping. Okay, prototyping is like, आपने अगर इलेक्ट्रॉनिक डिवाइसेस देखे होंगे, रिमोट या कोई भी डिवाइसेस देखे होंगे, इफ यू हैव ओपनड इट, देयर इज अ ग्रीन काइंड ऑफ सर्किट बोर्ड. ओके, अगर कंप्यूटर में होता है तो वी कॉल इट मदरबोर्ड. ओके, अगर वो और किसी डिवाइसेस में होता है, वी कॉल इट पीसीबी, दैट इज प्रिंटेड सर्किट बोर्ड, वेयर ऑल द कंपोनेंट्स आर फिक्स्ड. ओके, आपके जो इलेक्ट्रॉनिक डिवाइसेस होते हैं, वो जिसमें जितने भी उसमें पीसीबीज होते हैं, जितने भी उसमें ग्रीन कलर के इलेक्ट्रॉनिक सेटिंग होती है, all the electronic components are fixed uh, using a soldering system. So to but to test the circuit, whether your circuit is properly working or not, first what we have to do, we have to create a temporary circuit to understand whether your circuit is properly working or not. So to create a temporary circuit or prototypes, it's been called prototype, we use a component that is called breadboard. Okay, so the next question arises, like, why it's been called breadboard? So can anyone answer me in the chat why it's called breadboard? How many of you are able to log into this platform, Tinkercad? Can you write why, if you are being able to write to log into this platform, Tinkercad, in the chat? Okay. Okay. So why do we call it a breadboard? It's a very funny answer, which a student can relate to. Because it looked like a bread. It looked like a white color bread. Okay, you might have seen white color bread that you use in your daily life. It has multiple holes in it, right? So this device look like a bread, white color. It has multiple holes. So that's why for the login credential, you can yeah, it looked like a bread. So for the login credential, you can use your own Gmail ID. Okay, go to the personal account and use your own Gmail ID to log in. Mr. Akshat is also there, so he will be assisting with all the chat which is coming. So in the meanwhile, if you have any problem, he will assist you in that. So because it look like a bread, okay, it has multiple holes, but these holes are not random. Okay, so as you can see, when I put my cursor on the first hole of a upper or a lower rows, okay, there are two types of rows here. One is upper rows, same is with the lower rate, and then we have a mid one. Okay, so when I put my cursor on the first hole of a upper or a lower row, we can see all the line in the horizontal, all the holes in the horizontal rows get light up. Okay, so it means this is the same connection. So when you put any put any connection or wire in any of this hole, okay, it will be at a same potential throughout the line. But what happens when you put the cursor on a middle holes? You can see all the vertical connection are at a same potential. Okay, are at a same connection. So these holes are connected with a metallic plate. In if you open this device, if you find this device, you might have seen in your physics lab also or in your graduation. So when you open this device, there is a metallic plate behind it. Okay, so all these holes are connected with the same metallic plate. Same thing happened in this middle one, where the metallic plates are in a vertical direction. Okay, so to create a first basic circuit that we are discussing about, what we require a 9-volt battery. Okay, so first of all, we require a battery. Let's take a battery. We have a 9-volt battery. Next thing what we require a light, LED light. Okay, we have one LED light. We require a resistance. Okay, I have taken resistance. What else? A switch. Okay, so these are the component that we'll be using to create a circuit. Okay, where we'll be learning how the basic circuit work, how the switch can control the flow of electricity, and what is the use of resistance in operating any devices. So now LED, when we talk about LED, LED stand for light emitting diode. So it's a semiconductor device. Diode, you might have already been teaching to the students. It's a semiconductor device. It means it can start of you conducting after a certain voltage is being applied. Okay, so if LED, you might have seen in every decorative lights, or there's LED bulbs now. Right now, previously we were using uh, uh, different kind of fluorescent tubes for lighting up our houses, but now the focus are all being around the LED lighting. So this is a very common components of electronics that we are using nowadays. Okay, so it has two part. One is anode and another one is cathode. Okay, so anode, so anode, as you have already been aware, anode is something that is positive and cathode is something that is negative. Okay, similarly, if we talk about our battery, okay, then there's also two terminals over here. We have a negative terminal and we have a positive terminal. Okay, so now there is some confusion among the students. They don't understand the difference between a battery and a cell. Okay, so this is a question that arises first of all, that what is battery and what is cell. So cell is a singular unit. Cell is a singular unit of our system, and battery is a combination of more than two or such two or more such cell is called a battery. So when we have individual unit, like you are going for a pencil battery that we use in a remote. So if you are purchasing one battery, one cell, it's called cell. But when you put two cells in your remote, it become a battery. Okay. So similarly here, if we talk about 9 volt battery, it might have multiple cells in it. Okay. So let's start making the circuit. Move this battery at one terminal, and using this rotate option, rotate it accordingly so that you can use the terminals of positive and negative in a battery. Similarly, let's arrange uh, these LEDs also, LED and resistance. Okay, I'm going to tell you how to make a connection. First of all, we have to connect the positive terminal to the positive and negative to the negative part. Okay, so why we can use the both option like positive and negative here only, but why I'm using the positive and negative in a upward and downward way, because it's easy to remember the basic circuit. You might have seen the whole diagram and everything, so whenever you are recreating it, it's easier to explain to the children when you have this connected in such a way. So let's connect the positive. Click on the positive terminal. Here the wire will get stretched and connect it with the first hole of a positive terminal. So this is how you can create uh, a connection between a positive and a negative, or you can use this kind of setup also. Like you click on it, you take it straight, you again click. Now the wire will bend, and then when you reach the hole, you click again. So it is more you can say clear right now. Similarly, we are going to do with a negative. We are going to click on it. Okay, we are going down in a parallel way, and after clicking it, we are going to connect it with a negative. Okay, so in a uh, in a circuit, basically the positive is shown with the color of red, and negative wire is being shown with the color of black. Okay, so this is the wire connection in the different electronic circuits or different electrical circuits also. That live wire where the current is basically flowing is being shown as a red, and the black color is being shown as a ground or a negative. Okay, so we have connected positive to the positive terminal of this breadboard and negative to the negative terminal. So now if we connect this uh, LED directly to this basically directly, if we connect the wire directly to the LED, what will happen? Our LED will get fused, because the potential required to operate this LED is quite low. It's around 1.5 volt, and the voltage that is coming from this the battery is what? It's 9 volt. So if we connect it directly, like if we take a wire from here and connect positive with the positive, and similarly connect negative with a negative. Okay, this is a simple connection that I have done, direct connection, where I have connected batteries uh, battery to the LED. Okay, the positive, see, this whole line is at a same potential, and here all the vertical line in the same potential. So to connect the positive to the positive of a battery, we just have to connect one hole that the positive leg is connected with, and to connect the negative, we have to connect the hole that we where the negative terminal is to the negative of a battery. So now if we run a simulation, okay, if we click on start simulation, we will showing that the current voltage through LED is quite high, and this LED is shown that it's been blown. Okay. So this is the wrong connection. That's why. So to reduce this current supply, what we require, we can use a resistance, or what we require, basically we require one more IC, that is called 7805. Okay, so it's basically a regulator. So you might have heard about voltage regulators in your home appliances also. Like if you have a television or a fridge, okay, it's been basically connected with a voltage regulator. So what is the function of voltage regulator? It regulates the flow of a voltage. So if there is any fluctuation in a voltage, like if the voltage is very high or if the voltage is very low, what it does, it regulates it. It makes the flow of output of a voltage a common one. So this IC that we are using right now, it's a 5-volt voltage regulator. Okay, so what will happen, whenever we apply any voltage to it, it will give a constant output of 5 volt. Okay, so here you can see there are 3 pins in this voltage regulator IC. One is a input pin, second is a ground pin, and third one is a output pin. So we have to connect input pin with a 9-volt voltage supply. So we have taken a wire where we have connected with the first hole and connected it to a first terminal of a voltage regulator. Let's take the color red so that you can understand how the positive current is flowing in a circuit. Similarly, the middle one, that is a ground, it has to be connected with a negative terminal. So I have taken this connection where I have connected the middle one with a negative wire. Okay, so this whole row was a negative, so we have chosen one wire and we have connected it with a negative. Now the output that we'll be getting from this will be 5-volt positive. So to connect it with the LED, we have to take this output here. Okay, and we can directly connect it with the LED. But what will happen, it also, like 5-volt is also quite high for the LED. So before connecting it with the LED, what we had to do, we had to reduce this voltage further. Okay, so to reduce it further, we will require a resistance. Okay, so resistance is this kind of electronic circuit. This kind of electronic component is a resistance. Okay, just a minute. Sorry about that. So this is a resistant that we use. Okay, it's an electronic component which reduces the voltage flowing through it. Okay, it's like a tap that we have given the analogy of. Okay, so the resistance, let's take the resistance of this will be 330 ohm. So right now the value is 330 kilo ohm. Let's take it 330 ohm. So this will be the color option, that is orange, orange, brown. Okay, we'll be discussing about the color coding in next session. Okay, so this is how I have connected 5-volt to a resistance. Okay, now this term, this whole row, it's a 5-volt row. Okay, to make the connection, I just have to click on the first hole and connect it with the positive of a battery, positive of a LED. Let's change the color to red. Okay. And similarly, we have to connect a switch to make it operable. So the negative terminal of a LED, okay, it will be connected with the middle of a switch, and at the same time, the first terminal has to be connected with the battery's negative. Okay, so let's change the color to battery negative. Now this the first basic circuit has been completed. Now let's start the simulation and see. So right now the current is the LED is on, but when I click on the switch, it get off. Again, when I click, the LED start glowing. Okay. So as you can see, you can simulate the whole circuit using a simple software. So let's understand this circuit once again. You see, here we have a 9-volt battery. It has two terminals. One is positive, another one is negative. So what we have done, we have taken this positive and connected it to the positive of a breadboard, and the negative terminal, we have taken it and connected with the negative terminal of a breadboard. But since the voltage, the power that is coming from this battery is quite high, that is of 9-volt power supply, so we cannot directly connect it with the LED. Otherwise, our LED will get fused. Okay. So LED has two terminals, two pins. One is cathode. It means it has to be connected with the negative terminal of a battery. And another one is a anode. That is a positive terminal. So to reduce this voltage of 9-volt to a 5-volt power supply, we have used a voltage regulator called 7805 or a 5-volt regulator. Okay. So to connect, make a circuit, make a connection, you can see the positive current, the positive terminal is going here. Since this whole row is a positive, so I've taken one connection and connected with the first pin of a voltage regulator. So this is a positive connection going on. Similarly, if we talk about the negative, so I have connected the second one, that is a ground, to a negative one. Okay. Now the output that will be coming from this voltage regulator will be of 5-volt power supply. So we have to reduce it further. Okay, because 5 voltage is still too much power for the LED. It's like you are pulling a bike or a car with your bare hand. Okay, if the force applied by a car or a bike will be more in opposite direction, you will be dragged along. So similar is the case with a LED. So to reduce this voltage further on, what we have done, we have used a resistance. Okay, so this is like a tap that I'm giving the analogy of. So this reduces the 5-volt voltage further down to 2-volt or 1.5 volt, which the LED can properly work. Okay, so this is a positive power supply that is coming from the output. So that's why I have represented it with a red color. So we have connected one terminal of a resistance to a positive power supply, and the second terminal, that you can see here, terminal 2. So it's been connected to these holes. So as you can see, this whole row, the vertical row, is at a same potential. That is, how much potential is there? 5-volt. Sorry, 2-volt. Okay, due to the resistance, it is reducing the voltage. So we have connected this terminal to the positive end of a LED. Okay, that is anode, and at the same time we have connected negative with the negative terminal of a battery. Okay, in between this we have connected a switch. Okay, as you can see, this is a switch, a slide switch, where there are 3 terminals, 1, 2, 3. So we have to connect the negative to the middle one. Okay, if you connect it with the side one, it will not work properly. In a switch, you always have to connect it with the middle one. Okay, So we have connected it with the middle one. The first terminal we have connected to the battery. So now how the electron are flowing in this circuit. So this positive terminal is basically pushing the electron. So the electron is flowing from here, going to the voltage regulator, and then it's coming here and is flowing through LED, coming back and going from switch to the negative terminal of a battery. So this is how, sorry, I have given wrong. Basically, the current is flowing from positive to negative. The electron will be flowing from negative to positive. Okay, because negative will repel the electrons. Okay, so the current is flowing from positive, going to the first terminal of a voltage regulator, and then coming out as a 5-volt power supply, and then going from resistance where it been again reduced to 2 volt or 1.5 volt, and then going from the positive terminal of LED, coming from the negative terminal, and then coming back to the uh, to your battery. So this is how your electronic circuit has been completed. Okay, so this is how you can simulate an electronic circuit. So if you have any problem, if you have any query, you can ask me now. Any query in this basic circuit that we have done? Okay, so this is the first basic circuit that we have learned today. Okay, where is it used? It's been using, we can use this circuit in a torch. Okay, if you are using a torch, or you are using a bulb in a house. Okay, so this is what happening in your house also. The positive, or a live wire and a ground wire is connected to your uh, bulb, and when you switch on or off the bulb, it will it will get light up or remain off. So this is how it's been used. So it's been used in the torches, it's been used in your daily appliances. Okay, it's been used in your lighting of different components, decorative lightings. Okay, in the basically during the celebration events like Diwali and Christmas, we use decorative lighting. So the same connection is being used. Okay, so this is how a basic circuit works, and these are the practical example of those concepts where it's been using. It's been we can use these circuits. Yes, these sessions are being recorded. So yes, your attendance is automatically being recorded there. Okay, yes, we have used negative wire. As you can see, this is a negative connection. Okay, the LED is negative because LED has two terminal. One is positive, another one is negative. So negative is been connected with a negative color. So you can see this black wire. We are representing negative with the black color. No, it's automatic supported. You just need a browser. Like if you are using a Chrome, it automatically has a flash player, so you can use your Chrome and play the use this as a simulation. So there is no requirement for flash player or something like that. Yeah, it doesn't matter where you place the resistor. Okay, you can place it after the negative terminal also. Okay, it doesn't matter because it's basically at the end it's reducing the current flow of current in a circuit. You can use multiple LEDs, like coming back to it. So if you want to have multiple LEDs, so what you can do, like here what we are doing, we are connecting 5 volt, okay, and converting it into a basically 9 volt and converting it into a 5 volt. So instead of connecting this terminal to a LED, what you can do, you can delete this, and here you can directly connect it to the upper layer. Okay, so now lower layer is a 9 volt positive supply. Now upper layer is a 5 volt positive supply. So if you have to do a multiple connection with a LED, like let's take one another LED. Okay, let's take this one. Now let's change the color also. No, we cannot connect 9 volt to 2 volt because it will get burned out. Let's make this a green one. Okay, so we have taken one another LED. We have taken another color, that is a green one. Now you see this 5 volt supply, after going through the resistance, here we have diverted it to the first terminal. So this whole row is now 2 volt power supply. So to make the connection, you just have to connect it with the positive of the batteries. Okay, like here you have connected with the red color, here you have connected with the green color. Okay, now as we have connected the black one to the middle, okay, what you can do, you can connect, you can make another connection where instead of connecting it with the middle one, you can connect this to the side one. Okay, and at the same time delete this one and connect it with the middle one. Just using a same switch, we can control 2 LEDs at a go. Okay, so let me give you a description. So what we have done, we have connected the negative terminal with the first point of our switch, and the negative terminal of green one to the third option of a switch, and this middle one is being connected directly uh, with the battery. So when we start the simulation, okay, so as you can see right now the red color is glowing because the slide is on a left hand side. But when I click on the slide and it goes to the right hand side, the green color LED will start glowing. Okay, so this kind of switch is called DP-DT switch. Okay, this kind of switch is called DP-DT switch, where you can operate 2 electronic devices using a single switch. Okay, so similarly you can connect multiple LEDs, as you might have seen in a decoration lights that every LED is connected, multiple LEDs is connected in a series or a parallel connection. So same you can do with this also. Okay, so this is a concept that we have understood today. In the next session we'll be going deep into this, okay, because today's was the first session, so I have given a detailed view of these, how the system or how the software is being accessed, how the circuit has been made. But from the next class that we'll be having on the Thursday, okay, we'll be doing multiple activities, like we'll be learning about potentiometer, what kind of projects can be created from them. Okay, how different other electronic devices are being used, like you might have seen automatic alarms where when the sunlight or the room's light is on, the alarm will ring, otherwise the alarm will not ring, like clock will not ring. So this kind of system or photo sense register is there. So we'll be learning about those components in the next class. Okay, so we are concluding this session today from here. This whole recording is being shared on the YouTube also. So if you find any difficulty to understand any concept, you can go to the YouTube. You can access the video. The name of this circuit is a basic circuit, ma'am, that we do a simple circuit. Okay, the simple circuit that we learned in class 6, where we have connected a battery to the LED or a bulb, then resistance, then switch, and then negative terminal. So it's a simple circuit that we have learned today. The component that we have used are resistance, LED, okay, and switch, and a 9-volt battery power supply. Since we cannot directly connect 9-volt to a LED, what we have used voltage regulator. So what is the working of a voltage regulator? It reduces the voltage from 9-volt to a 5-volt, which can further be reduced using a resistance. Okay, thank you everyone for attending this session. It was nice meeting you all, guys, and we'll be sharing a feedback form. I think we on that day it was not shared. So after this session, I will get it shared. So please fill your feedback over there for any improvement that we have to do. Okay, thank you.